All right, we're back. We are on page 5, I guess. Yeah, of notes 20 of Calc AB. We're talking about areas of regions bounded by curves. What we're going to do on this page is something that's kind of interesting. So we are going to talk about, and I guess we've kind of run into this before. So for example, here we ran into, there were like 2 regions, right? And so we had to switch the top and bottom curve as we went through. Same thing here. So you have to make sure that you're always doing top takeaway bottom. So as we look at these regions, we want to find the area of the region enclosed in each figure, reproduce each figure on our calculator as best we can, which is to say exactly. And then we want to find the area. So one thing that I find like really difficult with this problem is keeping track of which curve is which. So what I'm going to do is I'm going to actually like highlight them if I can in different colors. So we have here, we have 1, so this is x squared minus 4. So that's going to be like, so I didn't say I was going to do a good job. I said I was going to do it, right? So that's x squared minus 4. You know what, maybe I should use a highlighter instead. I mean, I said I was going to highlight, but then I was like, I'll use a marker. This one, I believe, is x squared minus 4. And then this curve is the negative x squared minus 2. Oh my God. All right, look at that, doing the best I could, which was not phenomenal, but all right. Okay, so we have to do top takeaway bottom. So there's 2 different regions here that we're gonna deal with. So on this region, I'm drawing just a little vertical segment there. You can see that the top curve is the one that I highlighted in this color. And then the bottom curve is the one that I highlighted in the other color, which is this one. So we want to do the integral from, it looks like negative 3 to negative 2 of x squared. So let's do this. Let's say, well, let f of x equal x squared minus 4 and g of x equal negative x squared minus 2x. I'm actually just going to use a calculator to get the values because, like, I don't know. I don't think it'll be, we've done some fundamental theorem stuff, right? So we're going to do, and I'm going to like just continue to make my life a little easier. I'm going to highlight these in the colors they should be. So here and here. All right. So I'm going to say these are like purple and blue. I know like neither of those designations is probably right, but so we're going to do negative 3 to negative 2 of the purple minus the blue. So it's going to be the integral from negative 3 to negative 2 of the purple, which is f of x, minus the blue, which is g of x, dx, plus, all right, then it switches, right? And so on this interval, we have a top curve is the blue curve, and the bottom curve is the purple curve. So we're going to go from negative 2 to positive 1 of the blue minus the purple. We'll say plus the integral from negative 2 to, did I say 1? I guess so. To 1 of the blue curve, which is g of x, minus the purple, which is f of x dx. Okay, so if we were, I just like straight up don't want to do this by hand. Should I do it by hand? I mean, I guess. All right. You've talked me into it, I guess. So f of x minus g of x. So I really don't want to do this by hand though. It's like I want to rise to the challenge of doing it by hand, but also I don't want to do it by hand. All right, in the interest of this not being like 1,000 hours long, I will not do it by hand, but I kind of want to. So let's do a calculator page instead. All right, so the direction said we should try to reproduce this. I'm gonna put in a new problem, graph x squared minus 4, and then also negative x squared minus 2x. And then, all right, so if you look at like on the notes, it looks like x kind of is going from negative 4. So let's change the window from like negative 4 to 3. And y looks like it's going from negative 5 to 6. So negative 5 to 6. And then, I mean, that doesn't really look like the graph at all. It doesn't look like the scale, like the scale is like way off. All right, I think it's fine though. All right, let's see if we can do this. So the calculator has, so this is actually really interesting to me. So I'm gonna do menu 6, 8. I'm gonna go from -3 to 1. Lower bound is this, upper bound is 1. So it gave me 12 like 12 and 2/3, 12.667, right? The calculator knows to switch. It does a really good job with this. This is one thing that I'm actually very impressed with in the calculator. So if we had done, I'm gonna insert, no I'm not, I'm gonna insert another graph page and I'm just gonna like reproduce it. I'm not gonna change the window this time. If I do menu 6, 8, and I go from -3 to -2, I get that. And then if I do it again, menu 6, 8, and I'm gonna go from -2 to, can I just type it and it'll work? I'm not really sure. 1. I get this, and it didn't tell me what's the, well, what's the region? Menu 6, 8, -2 to 1. Why won't it show me? I hate it so much. All right, let's do it on the calculator page. All right, so I need to do, I'm just gonna store them the way that I had them. X squared minus 4, g of x is negative x squared minus 2x, integral f of x minus g of x, that's top take away bottom, -3 to -2, plus integral g of x minus f of x, comma x from -2 to 1. There we go. 12.667. So you get the answer no matter how you do it. I'm gonna say 12.667, or it's exactly 38/3. Okay, one alternative method. So I think you should do it this way, the way that we've done it, where you like break it up. There is an alternative method, so you have to watch out because this will be like not useful on multiple choice questions. If you have to do it by hand, this isn't useful, but the calculator can deal with absolute value. So you can actually do the integral from -3 to 1 of the absolute value. So I should use the template. The absolute value of f of x minus g of x. So what happens here is when f of x is bigger than g of x, the absolute value of f of x minus g of x is just f of x minus g of x. Perfect. When g of x is bigger than f of x, then f of x minus g of x is negative, which means its absolute value is the reverse of that. So the absolute value will be g of x minus f of x. So this way, the calculator does like all of that for you, and it just spits it out. That's an option if you have the calculator. If you don't have the calculator available, that it's not a viable option because doing that by hand, you basically have to break it down into what we did anyway. So let me go back. I'm gonna write that one down. But this is like a strictly if the calculator is available, right? So if all calculator and it's okay to do this, which usually the directions will like, sometimes the directions will just like exclude it. You could have done the integral from -3 to 1 of the absolute value of f of x minus g of x dx, and that would have spit out 38/3. Sometimes when you do the absolute value thing, it like, for whatever reason, can't get the exact value. I think it has to do with like how the calculator is dealing with it. I don't really know. All right, let's knock this one out. So we have a cubic thing and we have a quadratic thing. So I'm gonna highlight the quadratic thing first. So quadratic thing, and then I'll highlight the cubic thing. Kind of like this. I think the highlighting is really, it's really helpful to me. I don't know how you feel about it. So on our first interval, like this. So it's going to be blue minus purple. But first, let's see. So I made the cubic is blue, the quadratic is purple. Let's make some let statements. Let's say let f of x equal negative x squared plus 3x, and g of x equal 2x cubed minus x squared minus 5x. And then I, for my convenience, I'm going to highlight these again, because now I can just talk about blue and purple, which is what I want to do. All right, from -2, so you can see it, from -2 to 0, so on this interval from here to here, blue is on top, purple's on the bottom, so we're going to do the integral from -2 to 0 of blue minus purple. -2 to 0 of blue minus purple plus from, huge, from 0 to 2, purple's on top, blue's on the bottom, so purple minus blue. So from 0 to 2. 0 to 2 of purple minus blue. Okay, calculator. So what else could we have done? We could have done the integral from -2 to 2 of the absolute value of just f of x minus g of x, or g of x minus f of x. It won't make a difference. Either of those should work. So let's see. Let's do, I don't know. I mean, you can change your calculator up. I'm gonna insert a new problem, doc 4.1, and then calculator page, f of x is negative x squared plus 3x. G of x is 2x cubed minus x squared minus 5x. Okay, so if I do, let's use the templates this time. Integral -2 to 0 g of x minus f of x, so top take away bottom, plus integral from 0 to 2 f of x minus g of x, top take away bottom. I get exactly 16, which is mind-boggling. What if I do the integral from -2 to 2 of the absolute value of f of x minus g of x dx? I get that. What if I made it g of x minus f of x? So these are the things, like when you wonder, don't wonder, just do. We get this. All right, I'll try it on a graph page. I'm going to graph f of x and g of x. And I'll do menu 6, 8, lower bound -2, upper bound 2. I don't know, like 16. There we go. Not my favorite built-in function at all. Like, I don't know. Although the derivative on the graph, I think, is even worse. Like, there's one problem somewhere in the notes where I got the wrong answer, and I like couldn't work out why. So I will never use the derivative from the graph page. But there you go. We got 16 in all 3 different modes. We could also do it by hand and get 16, but that would take way longer. So, all right, pretty good. I'm gonna go back to the notes, and you can take a look at what I've written, although I think you mostly saw what I wrote. And then we will be back in the next video to do the next page. Moving along. Got 2 pages left in these notes, and then we'll move on to a new topic. So, all right, I will see you in the next video.